Today we're going to take time to talk about solving absolute value inequalities. This topic tends to be a little more difficult. I don't know why, but people seem to have some trouble with it. So we're going to take a look at these first two problems. And the first one asks us to take and graph the solution to this inequality on a number line. So let's go ahead and do that. I want to find out where the absolute value of the set of numbers is less than 6. So normally what I do is I put my 6 down here and say, okay, well, that means I have a filled in circle because it's less than or equal to. And I keep moving on down. Now the question is, do I go down forever? Well, as I go down past 0, I'm okay because all those numbers are less than 6. As I'm at -5, I'm okay. Keep going. As I'm at -6, I'm okay. But if I went over to -7, would the absolute value of -7 be less than or equal to -6? And the answer is no, because absolute value of -7 is +7, which is greater than 6. So in actuality, all I can really do is go to -6 and stop. Now, if I were to do the same thing on this side, where is the absolute value of x greater than 3? Well, again, if I put 3 down, fill in my circle because it's greater than or equal to, and move to the right, I could go forever because every number to the right of 3 is greater than 3. Now, it wouldn't make any sense to go to the left, or would it? Because if I have 2, doesn't make sense. 0 is not greater than 3. The absolute value of -2 is not greater than 3. But once I get to -3 and take the absolute value of that, it's actually equal to 3. So this number works. And if I go to -4, the absolute value of -4 is greater than 3. So my graph is going to look like this. Now if you remember from the compound equations that we just talked about, this tends to look like all the values in between two numbers, which is very close to an and type of problem that we saw in our compounds. This appears to be numbers going in opposite directions, which appears something like an or problem in our compounds. Right? Now there's a cheap and easy way to kind of remember how to do these. If you look at the absolute value sign and you look at the inequality, notice this says the absolute value is less than. All right? And in the words less than, if you add a D to that, like I said, it's cheap. Less than, it tells you that you're going to have an and looking situation. If you take a look at this guy right here, the absolute value is greater than or equal to 3, well, greater, you'll know that those are all like the or problems. Like I said, kind of cheap, kind of easy. Now, here's the deal. In each of these two, we really have two statements. We have the numbers less than 6, greater than -6, greater than 3, less than -3. So we're going to need to write two equations just like we did in our previous equality type problems. Let's take and solve this. If we have the absolute value of a quantity x plus 3 is less than or equal to 5, that's like the absolute value of whatever, I'm going to put a question mark, is less than or equal to 5. Well, we know that that's going to look something like this, because it's less than, and the value of whatever's in there is less than or equal to 5. Now, if I want to rewrite that, I could rewrite it like this. I look at my graph and say, okay, well, whatever's inside there is less than 5, but it's also greater than or equal to -5. And now I can just replace that question mark with the value of x plus 3, which is on the inside. So if I want to solve this now, I can take and subtract 3 to both sides of my inequality, thus getting 2x and negative 8. So my solution is all the numbers between 2 and negative 8. If I were to take and graph that on a number line, I would look something like this, and here is my solution. And really this is a less than type problem. If I move to my next example, this is a greater type problem, and again what I like to do is say, okay, well what if there's just, some random stuff inside here, put a question mark, and the absolute value of that is greater than 13. Well, we know that looks like, oops, you'll notice that that's just greater than, so I'm going to open circle to the right of 13, open circle to the left of negative 13. Alright, and this establishes how I'm going to set up my problem. So whatever is in here has to be greater than 13, and it's got to be greater than or less than negative 13. And since it's greater, we're using an OR. So in this case, we have whatever's inside, which is my x minus 7, is greater than 13, and my 5x minus 7 is going to be less than negative 13. So I have two equations that I'm going to solve. Add 7 to both sides. Do it on both equations at the same time, might as well. So we end up with negative 6 here. Divide by 5 in both sets of equations. No need to flip the inequality because I'm dividing by a positive. So now I have two possible solutions. X is greater than 4, or x is less than negative 6/5. There is my algebraic solution and my graph. This one's a little more complicated. Now the question is this an in-between type graph or is this an OR type graph? And like I said, it's important that you read the absolute value sign first and then look at the sign associated with it. So I'm going to put a question mark in here. So this absolute value is less than 6. So it's a less than, so it's an and type of problem. And if I were to take and graph that, then if it's less than 6, I'd have 6 to negative 6 and all that stuff in between. Now I graph the equation with the open circles because I have strictly less than, no equal sign, and now I'm going to write my equation. So since this is in between, I say that 2x plus 3 over 7 is less than 6, but it's also greater than negative 6. If I want to solve for this, I'm going to multiply all sides of my equation by 7. To clear the fraction, I get negative 42 less than 2x plus 3, which is less than 42. I'll then take and subtract 3 to both sides. Get negative 45 less than 2x less than 39. Divide by 2 to both sides. Get negative 45 over 2 is less than x, which is less than 39 over 2. And if I wanted to take and graph that, I do just like the following. And there's your solution. Now, like in any of these type of problems, there are some special cases. If you have the absolute value of a quantity and it's less than a negative number, well, when will that happen? Again, just put a question mark to say there's a whole bunch of stuff inside here, and it's going to be less than a negative 10. Well, the absolute value of anything is going to have to come out positive, so this will never happen. There's no solution to this problem. There's no sets of numbers. When you take the absolute value of that, it'll be less than a negative. Likewise, if I look at a problem like this, where is an absolute value of something greater than a negative number? Well, in this case, an absolute value of a value is always going to be positive, and a positive is always going to be greater than a negative. So this is all real number solution. So those are two special case problems. So we have our example that we've seen before of a number line, and we're supposed to write an absolute value inequality for this. Well, first of all, this is a little different than the ones we did before in that we have a set of values graphed between the 2 points. When we solved our equalities, we just had 2 points. But the concept is the same. If you remember before, we took a look at, well, where is the middle of this graph that we see? Well, if we start here and end here, we notice we have a total of 10 spaces between. So if we go right here, that's the middle. That's 6. And then on either side of 6, we have a total of 5. So this is very much like taking the middle value of 6, adding or subtracting 5 to that, and then saying we've got an absolute value, in essence. All right. Now, let's start here. Say x, 6 plus or minus 5. But since, notice, this is shaded in between, that looks like an and type problem. So and corresponds to less than. So I'm going to throw that right in here. Now, if I bring the 6 over by subtracting, I get x minus 6 is less than plus or minus 5. And we know that if we have a plus or minus, that's like using an absolute value. So we're going to take and tack on my absolute value. And since we have the open dots, it's strictly less than, not less than or equal to. And there's our equation. Very similar to the equality problems that we did before. It's just now we have to determine whether it's less than or greater than in the problem. So here's an example where the two quantities are going in opposite directions. So this is going to look like an or greater than after the absolute value. So again, what I'm going to do is I'm going to find the middle of the graph. I know that between 1 and negative 7, there's a total of 8. So if I count 4 on either side, that's going to split it. 1, 2, 3, 4 puts me at a negative 3. And on either side, I'm going to have 4. So that's like adding or subtracting 4. And that's going to be, once again, since we're moving to an or problem, greater than. If I add 3 to both sides, I have x is greater than 3, or x plus 3, sorry, is greater than plus or minus 4. Take away the plus or minus, put in the absolute value. And you'll notice in this case, since I have filled in circles, I have to go greater than or equal to. Now we've got a word problem. So the menu at Gene's favorite restaurant states that roasted chicken with veggies is typically 480 calories based on the size. It can vary as many as 40 calories on either side. So what that means is it means my calorie count could be in between two actual values. So if I start at 480 it could be as high as 40 more or 40 less than the 480. And if I'm talking about in between, I'm talking about a graph that looks very similar to this one here, and that looks like an AND graph. So that will be, my value is in between those two. So that's a less than. Bring the 480 over by subtracting. You get x minus 480 is less than plus or minus 40. To get rid of the plus or minus, I throw in the absolute value. And there I have it. Now the key for today is to remember, identify whether it's an AND or an OR problem, set up your two equations or your solution of an in-between equation, and then solve. But remember, there's likely going to be two solutions on each of these. Here are the problems to solve for the day. Make sure you fill out your lesson summary, and we'll see you tomorrow.